Large language models are exploding by the day. And in this video, I'll show you how you can kind of use Google PaLM API along with Neo4j. So without wasting any further time, let's kickstart the video. Google's Makersuite is essentially a developer tool that enables everyone with a Google account to access the power of PaLM API. So this right here that you see is basically a chatbot that I've created on the data that resides into a Neo4j database. So Neo4j Database is a graph database that scales really well. Some users can find writing Cypher queries a bit complicated, which is where what I've created using Google's Makersuite and PaLM API is an interface wherein you can ask questions to your database in natural language and you get the response automatically in the chatbot itself. So now I'll show you how the entire process works. So let's quickly jump to the actual implementation. So I'll quickly create a Neo4j database. All you have to do is you have to go to sandbox.neo4j.com, sign up, everything's free. You don't even have to upload your credit card details. All you have to do is create an account and click on new project. I'll use the most widely used project, which is the movies database or the movies dataset. So I'll quickly click on this and I'll click create. I've created some videos on Neo4j databases, which I'll kind of add in the description section of the video. Feel free to check them out. So the database is up and running. There are multiple options that you can explore. We look at open with browser to kind of visualize the overall graph that we have. And the next piece that we look at is connect via drivers. So when I click on the Python tab, here is a sample code that is available that you can utilize in order to connect to a Neo4j database using Python. So we'll kind of connect to this particular database using Python. And the driver details are given here. So you require this particular URL, which is the bolt URL. You require the username, which essentially every time is Neo4j. And the password keeps changing based on the URL that is given to you. So these are the three fields that you will require in order to connect to Neo4j database via Python. So this is one thing that I wanted to kind of highlight. Now I'll quickly open this particular database using the browser itself. So I'll click on open. The entire process of opening a Neo4j browser on your dataset, that is currently our movies dataset, may take a while, but once it kind of loads up, this is the screen that you would kind of see. So here you have a Neo4j terminal wherein you can write Cypher commands. In order to understand Cypher, I think they've given an introductory tutorial as well, which contains multiple parts. So you can kind of go through this particular aspect of Cypher as well. In my previous videos of Neo4j, I've covered Cypher queries in some depth, so you can kind of refer to those videos as well. But think of Cypher queries as similar to SQL queries, but you're trying to query a graph database as opposed to a relational database. So these are some of the commands that kind of help you understand Cypher queries as well. I'll quickly show you the graph structure that's there so that even you are aware of what the graph is and how you have to formulate a Cypher query in Google Makersuite. So I'll quickly type the command match n return n. So it gives me this particular diagram. So think of this as select star from a table equivalent wherein it kind of displays all the nodes as well as the connections between the nodes. So I'll quickly unhide the tutorial and I'll quickly show you the graph. So the graph basically has two node labels, movie and person. You will have different people contributing to the movie in different aspects, which is covered by the relationship types. So you have a person acted in a movie, you have person directed a movie, you have person produced a movie, you have person wrote a movie, and so on and so forth. So these are the relationship that exist in the graph. If I click on say movie, or if let me zoom into this particular say graph. So you have different artists here and you have different movies as well. So you have a movie called as V for Vendetta. This is one movie that I really enjoyed watching as well. But if you see the node properties here carefully, you have different fields in the node properties as well. So you have released, that is the release year. Then you have the tagline and then you have the title. These are some of the properties that are used for say searching and filtering out the data that is there. when I kind of hover over a particular, say, person node, the properties are born, that is again year, as well as the name of that person. So this is what exists. And then you have the relationships that is directed, acted in, and if you see, the relationships have a direction associated with it as well. So this is one unique piece about Neo4j databases as well, that you have directions associated with the nodes that are connected to each other. So if I have a person node and a movie node, chances are that most of the connections in this particular, say, database are from the person node to the movie node. So that is something that you have to keep in mind while formulating a Cypher query. So this is something that I wanted to show you as well. Now, if this part is clear, I'll quickly move to the Makersuite interface, wherein I'll show you how you can build a question and answer based system on this particular database, which is purely based on Neo4j, and how you can ask questions in natural language. So let's move to the Makersuite interface. So the URL that you have to visit in order to use Makersuite is makersuite.google.com, and you would have this particular website that would load in front of you. Now there are different aspects that you can play around. You can play around with the text prompt, you can play around with the data prompt or the chat prompt as well. For this particular activity, I'll only stick to the text prompt. So I'll click on create, which kind of exists within the text prompt. So I'll click here. So here is where I'll write a smart prompt that helps me convert natural language queries to Cypher queries. And the end goal is to take that Cypher query that is generated by the PaLM2 model and connect it via the Neo4j driver and get the response in form of a chatbot. So like, looks cool, right? So we'll quickly go through every process that I've just spoken right now. So the first thing that I'll type in is, you are an expert in converting English questions to Neo4j graph code. The graph has the following node labels, movie and person. So if you remember, there were two major categories of nodes that we had, movie nodes as well as the person nodes. And the movie node label has the following properties, that is released, tagline, title. The person node label has the following properties, name and born. And the graph has the following relationship types, that is acted in, directed, follows, produced, reviewed and wrote. I've given the PaLM2 model an indication of how the overall graph structure is, what are the different types of nodes that are present, what are the relationships, and what are the node properties that every node has. So this is something that I've already supplied. The next piece that I want to supply is the relationships. All relationships, that is acted in, directed, follows, produced, reviewed, wrote, start from the person node to the movie node. So person nodes to the movie nodes and not the other way around. So all of the verbs that you think of, a person is doing something for a movie, which is what I want to capture, given Neo4j databases have direction in them, right? So if this was not directional, I wouldn't have cared so much about, say, giving this particular input prompt. But given that Neo4j is all about, say, directions, where does the relationship start from, I have to be very cautious of how I kind of formulate the prompt as well. Next up, what I'll do is I'll give some few short examples so that the PaLM2 model is able to identify English query to Cypher query. So let me push that piece as well. List down the 5 movies that released after the year 2000. The Cypher command will be something like this: match M movie where m dot released is greater than 2000 and return m with a limit of 5. This is the first example. Now I'll enter in the next example as well. Give me the list of all people who acted in a movie that released after 2010. And here is the corresponding Cypher query. All of this is something that I've picked up from the default examples that exist in the Neo4j window that I just showed you. And now I'll paste in the third example as well, which is where it contains direction. So name the director of the movie The Matrix Reloaded. So match M movie, and here is where you have the direction coming into picture. Directed by person. So person is directing the movie where the title is Apollo 13. So I'll say, so the question is wrong, right? So Apollo 13 is the movie, the movie Apollo 13, and return p dot name. So this is the third example that I have.
And finally, I'll have don't include the triple quotes that are there and /n, because cipher queries, once I want to run it, say on using the driver, I want it to be in a single line and not multi-line, which is where I don't want the /n in the output. And once all of this is here, I will insert a text input. Name the director of the movie V for Vendetta. When I click run, here it's kind of created the cipher query for me. This is how amazing PaLM 2 model is. It's given me, based on what it has understood from the prompt, it's given me a proper cipher query with the direction. So the direction is also of paramount importance. So it's given me the cipher query with the direction, and here is the output that I have. Simply amazing, right? So now this is the input, and finally what I want to do now is I want to create a Python equivalent of this so that I can utilize this going forward. So what I'll do is, here is where you have the option of get code. You can either open the entire piece in Google Colab, but for now I already have a Google Colab session running. I'll only quickly copy the Python piece from this particular section. So I'll say copy and I'll go to the Colab section. So here is my Google Colab session. I already have the PaLM 2 API key in form of a JSON file handy with me. I don't want to disclose my API key, which is where I'm kind of using this particular JSON file. If you too are kind of worried in terms of how to get the API key, all of this is mentioned in the website very clearly. I'll quickly show you the website as well. So here, when you press get API key, you will kind of get access to the API key, and then you can utilize this going forward. So this is one thing that I wanted to show you. Let's go back to the Colab session again. I'll need a set of installations. So I'll need Google Generative AI. I'll need a Neo4j driver. I'll display the output of the chatbot in Gradio, which is where these three dependencies are the ones that I require. So I'll quickly run this. So the Google Generative AI application is installed and it says that I must run the runtime. So I'll kind of build the other dependencies as well and then click on restart runtime. This is required if you're using Google Colab, wherein you will have to restart runtime and then trigger the entire workflow again. So everything is installed. I'll quickly go and press restart runtime. Keep in mind that if you click on disconnect and delete runtime, then you will have like a new server allocated to you, which is something that you don't want, right? So all of this output looks messy, which is where I'll clean all of this, given that the installation is done. Now I'll go to the import section, wherein I'll say import google.generative AI as PaLM, import base64 JSON, Gradio as gr, and from Neo4j import graph database. So I'll quickly import this. Now the next piece is I have to supply the PaLM 2 model with the API key, which is where this particular piece of code comes in. So I say with open PaLM 2 secret key.json as f. I load the data from the JSON file into the variable data, and then finally there is a key called as API key, which has the value as the actual API key value, which is what I load into the PaLM 2 model. So I'll quickly run this. Now what I have to do next is I have to basically copy all of this input that is received here as a function in Google Colab. So all I have to do now is I have to copy things from this particular instance to the Google Colab session. So I'll go there. So I'll paste everything here that I'm generating from there. I'll remove things that are not required, which is something that I've already imported, right? So I have the input here. I have the prompt. Input is something that I'll take directly from the function. So I'll remove this. And I'll say, I'll create a function called as def get answer, and the input will be the input variable. So input here. So I'll have to align the entire function properly. So prompt is something that will come here again. So I'll include the prompt. So finally, I also have to return the response, which is what I'll do here. So response defaults prompt equal to prompt. And this is what I have here. And then I basically return the result, response.result. So this function is ready, up and running for me. So this is what I have here. Now let's check if this particular function is working fine or not. So I'll say, I'll call get answer, and I'll again ask the same question, who, where, the actors in the movie V for Vendetta. Let's see what the cipher query is. So here it says match P with person acted in and movie, where M dot title is V for Vendetta and return P dot name. So it's kind of giving all the node values with P dot name, where the movie is V for Vendetta. So for people who have acted in V for Vendetta, which is what this particular relationship signifies, so there all the people who've acted in this particular movie are returned by this cipher query. So our cipher query in Python in Google Colab is working perfectly fine. Let's move forward. We have like a long journey ahead. What I'll do next is, if you see here, there are some slash n's that are coming which are not relevant, which is something that I'll kind of take care using a function as well. So the next thing that I'll do is I'll quickly initialize the driver. So this is the command that I'll be utilizing for connecting to the driver. So it says bold URL, username and password. So username is generally Neo4j. I'll kind of paste the bold URL as well as the password. And I have the driver up and running as well. So I've initialized the driver. I have my PaLM2 model set up, which kind of generates cipher queries for me using natural language. So let's keep moving forward now. Now the result can be multiple answers as well, right? So when you have who acted in a movie like say V for Vendetta, you will have multiple answers that come up. When you connect to Neo4j via the driver, the response comes in chunk by chunk, which is where you will have to accumulate the results as well. So there are a couple of functions that I'll define in order to get the result that I desire. So the first thing is extract query and return key. So the reason why this becomes very important is whatever input query result that you generate, the first thing is I don't require slash n's, which is where I want to clean the query by substituting the slash n regular expression pattern. Wherever I encounter a slash n, I want to replace it by a space, which is what this particular query is doing. If there is a cleaned query, then what I also want to do is the result that is populated using the Python driver, when I connect to Neo4j, it will have a key value pair where the key is always the property name. So when I return, so if you look at this particular output as well, it says return p dot name. So if I have to return all the names of the characters that are there in the movie, then it will say p dot name and it will be a row wise result, which is what I want to accumulate. And I want the entire process to be automated without me having to specify that this is the key that you should desire or extract for. Which is where what I've done is I've again created a regular expression pattern called as RET pattern, which is the return pattern. Anything after return is what gets captured here. So if this is my query, the first activity that I'll perform on this particular query is to remove all the slash n's. And the next piece is to remove p dot name, which I'll utilize as a key going forward. So I'll quickly run this and show you what I intend to do with everything. But before that, I'll also have to import the regular expression module, which is import RE. I load this function into memory. Now, what I do here is I say extract query and return key from this particular function call. So let's see what the result is. So this will generate the query for me, and this will clean the query as well as give me the values after return n. So let's see the output here. So here this is the cleaned query, which is the first part of the tuple that has been returned. And finally you have p dot name, which is something that comes in after the return statement. So this is one function that I wanted to really utilize in order to get the results up and running. The other function that I require is, say for example, the results are basically a list of values. How do I display a list of values in a really good formatting based on the data set that I have? So if I have a result which has 3 people's name in it, okay, if there are 5 actors in the movie, for example, so I want comma separated string wherein the last entry should be an and, which is where this function comes in. So if the length of the names is 0, return a empty string basically. If it's 1, return the name as it is. Else format it till you encounter the last element. Once you encounter the last element, and add a and to it. So this is what I have here. So I'll load this particular function in memory as well. So Just for reference, if I say, so just for everyone's reference, if I type in say Sachin, Virat and Rahul, so the result of this particular function will be Sachin, Virat and Rahul. So who are the cricketers in India team? So this is how the result would be kind of say formatted and shown in the chatbot as well. Finally, after doing all the heavy lifting, I'll now create a function called as run cipher on Neo4j, which is what I'll kind of display here. So this particular function, which is run cipher on Neo4j, it accepts the input query and input key. I'll come to what input key is, but all the results that are populated using the driver output will kind of flow into this particular empty list. I initialize a session. I pass in the input query here, which is session.run, and I get the result. The result will have multiple records which I'll have to traverse, which will be basically a list of values. So I'll keep appending the result into this particular empty list that I had created, which is out_list, and finally I'll close the driver. If the length of the list is greater than 1, then I'll format it, otherwise I'll return the list as it is. Okay, so this is the function that I have. The input query is the cleaned query that was generated in the function here, which is this particular cleaned query. The extracted string will basically be passed into this particular record as a key. Okay, so when I run this function is also ready in memory now. I've already initialized the driver. So now if you guys want to look at how this particular response pans out, I'll take the entire piece here and I'll run it one at a time so that even you are aware of what is happening. So the first result is the query and then the string. So query and string, I'll just say 1 so that there's very little confusion in terms of the nomenclature. So when I now pass all of this here, I'll get the results in the format that I desire. So when I run this, it says who were the actors in the movie V for Vendetta. So if I show you the question, this is the question: who were the actors in the movie V for Vendetta? This particular function was able to generate the cipher query from the PaLM 2 model. It was able to then process and remove unwanted things that I required, which is the /n's that were there. I was able to extract the values of the return statement, which I later on pass in here as the input key, which kind of helps me extract all the values which are corresponding to p.name. And finally, I pass the query and string 1 to this particular input here, which kind of runs it on the actual Neo4j database and returns the result in this readable format. So you have John Hurt, Stephen Ray, Natalia Portman, and the other actors which are there, right? Now I'll create one more function that kind of does this in a more streamlined manner for me, which is where I'll create a simple function to generate and execute cipher queries. So this is what I'll do here. I'll kind of create a function to do the exact same thing that I've done there. Finally, I'll also create a chatbot. So this is the chatbot interface that I'll require, and this is something that I've already utilized in a lot of my last previous LLM videos. So I'll quickly run this. Now the chatbot function is basically used for saving state and giving out the output in the chatbot interface created in Gradio. The driver is initialized. The only piece pending is our chatbot interface, which is what I'll kind of now create here. So I'll quickly run this. So I'm able to create a chatbot interface with only one line of code, wherein I define the function which is chatbot. Chatbot here is taking in the input, passing in the input through generate and execute cipher query, which takes in the input, generates everything which is the final output that we require, and then appends it to this particular value. So if you see here, generate and execute query takes in the query. The query is then passed to get answer, which is where Google PaLM generates the cipher query for us. I do the pre-processing that I require, which is the return key and removing the /n's and the other stuff that we've done. There are two variable outputs here, generate query and generate key, which then run on the Neo4j database that is up and running. Okay, So now when I quickly run this, here is the interface that I have handy. So it's kind of loading right now. Let me click on this particular link so that I have the entire interface to play around with. So let me start by asking which year did the Matrix movie release. So the year it says is 1999. Okay. So here it was like a one word answer, which is where none of the processing was required in terms of the list output. So the next question is, who was the producer of the movie The Matrix? So the producer was Joel Silver. Who was the director? So here you have two results, right? Lana and Lily. So that is what you see here. Who acted in the movie The Matrix? So these were the list of actors that kind of acted in the movie The Matrix. If I say The Matrix Reloaded, so here you have a different set of actors which may or may not be the same, but yeah, I mean, and when did so if I ask the same question again, when did The Matrix Reloaded release? When did the movie The Matrix Reloaded release? So I'll remove this release, and here it says 2003. So the first movie released in 1999 and the next movie released in 2003. The beauty of this particular solution is the backend is a Neo4j database. This is how amazing this solution is. The backend is a Neo4j database where you kind of have to write complex Cypher queries to get things done. The good part about this entire solution is all of the communication that you're doing is happening in natural language through the Google Palm 2 models. You've not spent time writing tons of code in Google Palm 2 as well. All you've done is you've created a very smart prompt that kind of does the heavy lifting task in terms of making the Palm 2 model understand in terms of what you want to achieve. And finally, you have the results ready, right?
Well, this is all that I had in today's video. I hope you found this informative. If you really like the content that I'm creating on large language models, it would be super motivating if you can press the subscribe button and also press the bell icon to be notified for amazing videos that I plan to create in the future. Thank you so much for watching the video.